Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 11, 2025, about 5 days ago. The big hook is a dead simple visual overlay that adds shooting lines and scope reticles to camera views, and that alone boosts manipulation success rates, especially on long horizon, alignment-heavy tasks, with gains like pi0 improving from 85.2% to 91.0%. The paper is titled AimBot, a simple auxiliary visual cue to enhance spatial awareness of visuomotor policies. And as we'll see later, the implications for training are quite significant. Beyond accuracy gains, the method runs in under 1 millisecond per image, needs no architecture changes, and outperforms heavier guidance baselines in both simulation and real robot trials. Building on that, the tweets highlight a simple takeaway: draw an aim, get better policies. One shows a demo clip, the other summarizes the idea, with moderate engagement around 170 likes. Alright, this overview panel shows how the overlay works end to end. On the left, the raw global and wrist views feed into a central diagram that computes a starting point from the end-effector pose, interpolates midpoints from the gripper orientation, then finds a stopping point using depth. Moving right, the system draws a shooting line on the global view and a scope reticle on the local view, which then flow into the Visuomotor policy for closed-loop control. Next, this example sequence shows the overlays in action across front and wrist views. Focus on the full grid first, where the top row displays global camera shots with a colored shooting line from the gripper toward the stopping point, encoding pose in open or closed state. Then look at the bottom row, where a green crosshair reticle sits at the projected stopping point, with line length shrinking when the surface is far and growing when it is near, giving distance awareness for fine alignment. Moving to the results, this real robot table compares 5 tabletop tasks across 3 backbones, with and without the visual overlay. Focus on the overall row at the right. Successes jump notably. For example, Open VLAOFT goes from 21 of 50 to 36 of 50, pi0 from 27 to 43, and pi0 fast from 42 to 47. Looking across columns, the biggest lifts appear on bread in toaster and egg in carton, where precise alignment matters most. Now let's zoom into the simulation table that breaks results by suite. First, look across the full grid to see 4 columns for the Libero suites and a final average column. The consistent story is strongest on Libero long, where Open VLAOFT climbs from 87.5 to 91.2, pi0 fast from 81.6 to 87.1, and pi0 from 85.2 to 91.0. The average column confirms steady gains across models. Okay, this panel lays out the 5 real robot tasks used for evaluation, giving a visual sense of difficulty and alignment needs. The full strip shows fruits in box, ball in drawer, bread in toaster, place coffee cup, and egg in carton, each with the green shooting line drawn from the gripper toward the intended contact point. Building on our earlier results, notice how the scenes demand precise end-effector placement, especially the toaster slot and the egg carton lid, where the overlay's spatial cue directly supports tight, contact-rich maneuvers. Building on that, 2 takeaways stand out. First, adding simple spatial overlays like shooting lines and scope reticles gives policies clearer end-effector to object geometry, which boosts success especially on long, alignment-heavy tasks at under 1 millisecond per image. Second, the approach stays model-agnostic, requiring no architecture changes. End-effector means the robot hand. Thanks for listening. I am Alex, signing off from AI Research Roundup.